Okay, so welcome back. And we are in the section 2 portion of our worksheet. And we're going to talk about data and data types um, in this section. So here it reads, most data sets are organized into spreadsheets, just like this. However, very large and or complicated data are generally organized through a database program such as SQL or Microsoft Access. And my husband is a programmer and he works with SQL all the time with the databases, big, huge databases. Okay, but that aside, let's talk about this example of the data spreadsheet. So here we have variables listed across, and variables are characteristic of a person or thing, an observational unit that can be assigned a number or quantity or a category. They're called variables because they may vary from one observational unit to the next. For example, gender varies from one to the next. Age varies from one to the next. GPA varies from one to the next. So they are variables. So let's take a look at how many variables are here. We have age, we have gender, study preference, and then GPA, CT, sessions attended, the number of CT sessions attended, and club membership. Okay, so observation units are the people or things that data is being collected from. So here in this exercise, and whenever we're doing an exercise, I want you to stop the video and ponder over the answers first before you actually hear what the answers are. So this exercise says, determine their observational units and variable necessary to determine the average number of students per stats class in California. So stop the video here and think about what would be the observational units and the variable. Okay, so I assume that you guys already thought about this question, and it's not as easy as it may seem, and a lot of students, not that they make mistake, but well, think differently about this exercise. So, and if you don't actually ponder yourself, then you don't have that learning effect as much as learning effect as you would if you first were thinking about it by yourself and even made a mistake. Not a big deal. We learn from mistakes. Actually, it's true. The research shows that we learn from making mistakes more than we learn if we never make a mistake. Okay, so mistakes are good. But anyway, so what we need to think about our spreadsheet and what are we going to put in that spreadsheet. And a lot of students, would they say at first, we're going to ask students. Okay, let's make that spreadsheet. So we asked student 1, student 2, student 3. And okay, so those are our, let's say that students are we're collecting data from them, and so they're our observational units. And what are we asking them? Well, you may say, so basically, what are we filling our second column with? So the first column is student 1, student 2, student 3. We could put their names, but what is it going to be in our second column? And you may say in the second column, we're going to ask them how many students are in their class. And let's say in my first class, we asked the student from one of my classes, and let's say we have 39 students in that class. And then in my second class, the student from another class says, okay, I have 45 in my class, one on the wait list, okay, maybe 46. And then the student 3 happened to be again from the same class as the student 1. And then we're getting the same number from this student as we got from the first student. So we have a repeated number just because we picked a student from the same class. So this would give us an error, wouldn't it? We would get actually a better picture if we actually asked teachers who have access to the rosters and asked the teachers how many students are in their classes. This way, we would not get repeated answers that basically throw off our calculations. Or we could contact administrators and collect the data from them, the representatives from admissions office, collect data from them. This way, our data would be more accurate, okay? So for this spreadsheet, I would ask different teachers, teacher 1, teacher 2, so forth. And then, so not this spreadsheet, but this spreadsheet. So our observational units would be teachers, and the observational variables would be students enrolled, number of students enrolled in each class. So I hope this helps, and we're moving on to the types of variables. Okay, so let's talk about data types. So first of all, what is data? Data is any information that we collect from our study. So it could be, we could collect information through surveys, through observations, through experiments. There are different methods for collecting information, and we're going to be talking about those methods shortly. But so data by itself could be categorized in 2 big branches. So the first branch is categorical data. Categorical data. Or basically, and then also it's also called qualitative data. So qualitative data is non-numeric data. So it could be, for example, colors, it could be eye color, it could be hair color, it could be colors in general. It could be gender. It could be yes or no questions. So something that cannot be measured. Another type of data that we're going to be looking at is numeric variables or quantitative. So numeric or quantitative data. And that comes from measurements, okay? Measurements like weight, counts, how many TV sets each household in California own, for example, how many cars, how many people live in one household, how many children do families have, I don't know, weight of average weight of whale versus guppy fish. Okay, so all of this is numeric or quantitative data. The quantitative data comes from measurements. Okay, so I just wanted to go back really quickly about categorical or qualitative data. It could be represented by numbers. So for example, zip codes. The zip codes are numeric, right? But they don't mean, they don't bear the same meaning, numerical meaning as the quantitative data does. It just labels a territory, okay? Or, for example, there's college IDs, right? That are numeric, and they identify people, but they don't. Those numbers do not. They do not follow the same rules as numerical data does. So, for example, if you add a 1 to a college ID, that just means a different user. It doesn't mean that the quantity just increased by 1. The number of users is a numeric or quantitative data. And when we have a new user, it does increase by 1. Okay, so hopefully this helps. So let's talk about the types of the subtypes. Okay, so these two big categories, the categorical and or qualitative and quantitative data, they are further divided into subtypes. Okay, so for the quantitative data, we have discrete, and we have a continuous data. Okay, so let's talk about the difference between the discrete and continuous. So discrete data, it's basically data, we have just certain points, okay? So for example, when we count the number of cars each household possesses, we're gonna have numbers from 0, 1, 2, 3, 4. So counting numbers, right? So we're not gonna have any number like 1.75. We're not gonna have fractions, we're not gonna have decimals for that specific variable. However, sometimes we may have fractions. So for example, so this is cars. What about shoe sizes? Okay, so shoe sizes. We may have halves in shoe size. So we could have 6, and then 6.5, and then 7, and then 7.5. So this is also an example of a discrete data because again, so basically, the main characteristic of discrete data, it's not the entire number line, but certain points on the number line. So there are gaps between the numbers. It's not a continuous scale, okay? So we only have these specific equally distant numbers for discrete data. For continuous data, we're going to have the entire number line. So for example, if we actually went ahead and measured the length of a foot of a person with a ruler or whatever the very accurate measurement device, foot size or length rather, we would, I don't know what would be the shortest length. I don't know, but let's say it's 4 inches, and then we would have 5, 6, 7, 8. So our measurement could land anywhere on this line, right? It doesn't have to be specific numbers like 6.5 or 4.5, you know. It could be any number. It's a continuous scale. So this is a continuous data set, okay? Now, sometimes students confuse discrete and continuous by, okay, so I'll give you an example. Here's a good question where students get confused. So, for example, I tell you that a certain cow today gave exactly 5 gallons of milk. Would that be a discrete or continuous data set? And a lot of times students would say, okay, that's discrete because it's a whole number. It's a nice number, so that must be a discrete data set. Well, the question is, could it have been 5.1 potentially, or 4.9999? And the answer is yes. So that's why we're going to say that the amount of milk that one cow gives is actually, it belongs to a continuous data set, even though if it's going to be a whole number like 5 gallons on the dot, it is still potentially could have decimals in it, so that would be a continuous data set. Now let's talk about qualitative or categorical data. So it will have 3 different subcategories. And the first one is nominal. So nominal data set cannot be arranged in an ordering scheme. So for example, political party, the person identifies with, we cannot arrange it in any meaningful order, right? Or another example would be gender. Yes or no questions, again, colors, and that would represent a nominal type of data. Then the next one up would be ordinal. So the ordinal can be arranged in an ordering scheme. For example, military rank, GPAs, class level. So we could list them from, in order from basic to advanced, for example. And the next one is binary. So binary mode is basically your yes or no questions. That binary have only 2 possible categories. Those are binary. So now let's go ahead and take a look at our spreadsheet that we saw before, and we're gonna try and identify the data type for each variable here. Okay, so, and I encourage you to pause here and think about the answers yourself first, and then turn it back on, turn the video back on, and check your answers. So for the age is kind of tricky. So what we have here, we have whole numbers. So here I would definitely say this is a discrete data type. Quantitative, discrete. Okay, but my colleague Kelly was telling me about the experiment that she did, and they recorded the person's birthday, and they also recorded the times at which they questioned the person, so she could actually calculate the number, the age very accurately to decimal over years. So that in that case, that would be continuous set. Now for the genders, as far as I can see here, they only have male and female, so this would be a binary type. But if they had other types in here, like gender fluid or unidentified or something else, that would not be binary anymore. That would be ordinal. Now about study preferences, so some prefer to study alone, small groups, or big groups. Now this could be arranged in some sort of a scheme, so that would be ordinal level. And then for GPA, this is continuous. CT training, yes or no. So that was that's a binary. Definitely. CT session attended, numerical, again, it's a whole numbers, counting numbers, so this would be discrete. Let me write it down. And club membership, yes or no, this is binary. binary, and continuous. Well, this is also actually arguable about the continuous because it looks like everything is rounded to just one decimal. So we cannot have a value like 3.57. So it actually, still we have gaps between possible values like 3.5, the next possible value is 3.6. So there is a gap between 3.5 and 3.6. And we cannot have something like 3.572, for example. So I would actually label it as discrete as well. And here's the worksheet that we are working on. And so we discussed all of these types of data, and just wanted to show that everything is on your worksheet right here. I'm sorry, for some reason my voice got coarse really fast. And here, please check the skills that you're expected to know after this completing this worksheet for section 2. And we're moving on to section 3, collecting data.